Hey everyone, Mr. Skelton here. We are back at it for lesson 6 in unit 3, and today we are going to begin something brand new to you, and that is the complex number system, and more specifically how to generate and write complex numbers. So anything that is created because there's a problem, and that's how usually inventions occur, right? To fix something. And so what I'm going to do is jump into problem number 1, and then I'm going to kind of backtrack and explain kind of what a complex number is, how we write it, and how it fits into existing number systems that we currently know. And so let's take a look at number 1 here. And if you look at number 1, it says solve. And so as any good math student would do, if we were solving number 1 for x, we would subtract 25 from both sides, and we would have x squared equals a negative 25. And then we would go and take the square root of both sides, and we would get x equals plus or minus, we can't take the square root of a negative number. And back in your Algebra 1 days, we would write down this as our answer, because we can't take the square root of a negative number, right? What does the square root mean? It means something times something equaling the number inside of the square root symbol, where there's no two numbers that you can multiply that give you a negative. And back in our Algebra 1 days, we would write no solution. So that's a problem, and mathematicians became aware of that a long time ago. And so what mathematicians did is they decided to come up with a totally new number system, i.e. the complex number system, all right? And when we take the square root of a negative number now, we now have imaginary solutions. The answer to this is 5i, and I'm going to explain to you how we got that here in a second. So the complex number system, I'm going to skip slides a little bit, I'm going to jump around, and I'm going to focus here on our number system. And we started off with natural numbers, okay? Natural numbers are all your counting numbers that exclude zeros, so like 1, 2, 3, 4, 5, 6, 7, 8, and you can write the square root of 4 because that's 2. It does not include negative numbers. Your natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, all the way going to positive infinity. And then you have with the whole numbers next. So natural numbers are within whole numbers. Whole numbers just include zeros. So you'll notice there it's just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., etc. And then we get into what we call integers. And integers included negative numbers, which also include 0, which also include your natural numbers. So our number system just kind of keeps building. So integers like negative 1, negative 3, negative 17, negative 99, but also includes 0 and positive numbers as well. And then we got into another bigger category, which was fractions, right? Fractions are considered rational. The word in rational is ratio. Ratio means fractions. So 4/5 and decimals became part of that, because if you take a fraction like 4/5, or say example right here, 1/3. 1/3 is 0.33 repeating. So rational numbers include integers, right? Because you can write 6/3. 6/3 is a rational number because it's a fraction, but it makes 2, which is a natural number. So everything is included there. Well, then we got into irrational numbers. Those are numbers that do not repeat as decimals, and there's no pattern. So numbers like pi and e and the square root of 2, you can say the square root of 6. If you put those in your calculators, you get some really crazy decimals that neither repeat nor end. And that is the irrational numbers. And so up to this point, we have kind of lived in this box here that's kind of lighter shade of gray and darker shade of gray. Until now. Complex numbers. Complex numbers involve imaginary numbers or the letter I. Okay? And so this is your complex numbers here. And you can write everything as a complex number. You could write the number 5 as a complex number because you could write it as 5 plus 0i. And you're probably thinking, well, wait a minute, what does that even mean? So I'm going to kind of go back now to where we started. And now that you have some background information on the number system, complex numbers are written like this, in the form of a plus bi, where a is the real part, and the bi is the imaginary part, okay? So you have a real and you have an imaginary part. Now, let's get back to this problem right here. when we went and found the square root, took the square root of a negative 25, I already told you the answer was plus or minus 5i. Now, the plus or minus you should be aware of, because anytime you do the square rooting, you have plus or minus. Here's how we kind of break down this negative 25 and where the letter I comes into play. You basically get the square root of negative 1. The square root of negative 1 is I. That is something you're going to want to remember for a while, because that's going to come into play later on in Algebra 2 and definitely down the road in your mathematical careers. But the square root of negative 1 is I. You cannot take the square root of a negative number, so we came up with the imaginary numbers. So this is just I. The square root of 25 is just 5, so you have the square root of 25, which is 5, and you have the square root of negative 1, which is I. The square root of negative 25 times the square root of negative 1 is the negative square root of negative 25, so we get 5i. Okay? So that is kind of how it's going to work. Over here it says simplify the expression, so you have a negative 12. Well, you treat that just like you would if you had positive 12. We would break this 12 down into 4 and 3, and we know the square root of negative 1, because remember it's negative square root of negative 1 times 12, which gives you this. What is the square root of negative 1? That's just going to give you I. The square root of 4 is 2, and we have 2 radical 3. Now the million-dollar question is, where does the I go? It's always going to go with the number out in front. We don't put it back underneath the square root symbol. So if I wanted to give, or if I needed the answer to the square root of negative 12, it'd be 2i square root of 3. Okay? Same thing with 72. So I would always imagine that in my head as this. The square root of negative 1 times the square root of 72, which if you times those together gives you the square root of 72, negative 72. This gives you I, and then you break down 72. So that would be, what, 9 and 8? I probably should have went higher there, because I can get 3. 8 breaks down into radical 4 times radical 2, which is 2 radical 2, so I get 6 radical 2. And then the I goes here, so it's 6i radical 2. I could have broken down 72. I should have broken down 72 into 36 and 2. That's what I should have done, which would give me 6 radical 2, which gives me that right there. Okay? All right, so let's turn the page. And we talked about this already, but now let's get into complex numbers. So here is where we're going to get this A plus BI coming into play. All right, this is something you're definitely going to want to remember. Complex numbers always have the form of A plus BI, where A is the real and BI is the imaginary. Okay? So, square root of negative 18 plus 13. Now the plus 13, that's a real. 13 is a real number. That is a real number, and we're going to keep that out there. We're going to break down this 18. So this becomes negative 1. This is the square root of negative 1 times the square root of 18. We break down 18 into 9 and 2. And that gives us 3 radical 2 with the I here. Okay? And then the 13 comes out in front because that is the real part. And this is how we write our answer. We always put the real part first and the imaginary part second. So this would be 13 plus 3i radical 2. All right? Go ahead and hit pause and try number 5 on your own and see what you come up with. All right, so this is negative 1 times square root of negative 1, times the square root of 27. That's going to break down into 9 and 3, which is 3 radical 3. Square root of negative 1 is I. And so it's 3i radical 3. That's the imaginary part. The real part is the 5. 5 is just outside, so it's good. And that would be our answer there, 5 plus 3i radical 3. We got to keep them separate. We can't combine the real and the imaginary. We can't make this 8i radical 3. This is the real, this is an imaginary. They need to stay separate. Okay, so moving on here, this is the last kind of concept, is finding the absolute value, right? Let's take a quick second to review what's absolute value. It's distance from 0, which is important. Whoops, I'm off the page. Distance from 0. Absolute value is distance from 0. And so here it says the absolute value of 3 minus 4i. 3 is the real part. Negative 4i is the imaginary part. And so what we've done is we've taken the xy coordinate plane and we've turned it into real and imaginary. So you have the real axis is to the right and to the left, so positive numbers to the right, negative numbers to the left. And then your imaginary axis runs vertically, up and down. This is very common. So you just take it in stride. You take it apart. So you have a positive 3, 1, 2, 3, and then you have a negative 4i, 1, 2, 3, 4. Well, where's that point? That point would be here, 3 units to the right, and negative 4i units down, so that point would be right here. And you want to find the absolute value. Absolute value is the distance from 0, right? Now we're talking distance here, so we got to figure out what that distance, I'll call it x, is, and we can just kind of draw this, and we're going to make a right triangle. Every time you do this, you're going to make a right triangle. So this is 3, and this is 4 units here. Again, distance is always positive, right? Distance is always positive. So we're just going to do Pythagorean theorem. We're going to go 3 squared plus 4 squared equals x squared, because that is your hypotenuse, right? This is your triangle right here. If you can't see that triangle, you can always extract it out of the diagram. So you end up having this, 3 and 4. And you get 9 plus 16 equals x squared, so that's 25 equals x squared, square root. And since, yes, it's always going to be plus or minus 5, but since we're talking about distance, we're going to keep the positive root in this case, which would be 5. So the absolute value of 3 minus 4i is 5. That would be our answer. Good to go. Okay? Go ahead and try this one on your own. See what you come up with, and check back with me here in a second. All right, so if you want to, a lot of students will do something like this. They'll go R for real, and they'll put an I for imaginary, and they'll go negative 5, 1, 2, 3, 4, 5, and then positive 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it doesn't have to be perfect, but it's left 5 and up positive 12 units here, imaginary units. And we want to find this distance, call it x. So I just draw my right triangle. I could have drawn my right triangle across this way, and then it's just 5 units this way. It's 12 units this way. Again, distance is always positive. That's why I don't put a negative 5 here. You could, because you'd end up squaring it with Pythagorean theorem. But since we're talking distance and an absolute value, it's going to be positive. So again, it's 12 squared plus 5 squared equals x squared. 144 plus 25 equals x squared. It's going to give you 169 equaling x squared, square root. Again, since you did the square rooting, it should be plus or minus, but since we're talking about distance here in Pythagorean theorem, we're going to keep the positive root, which is just 13. So the answer to this question is just 13. All right? Sometimes you will come across a problem that will read something like this. It'll just say the absolute value of 5. And some students get tripped up because we're doing stuff like this, and they're thinking, well, where's the imaginary part? No, it's just the absolute value of 5. It's 5. And you're thinking, well, that's not very hard. And as soon as I do this, the absolute value of 5i, everybody starts to freak out. Well, what's the absolute value of 5i? It's just 5 units, right? If you think about that, if you go back to your plane, 5i, where is that? 1, 2, 3, 4, 5. That's 5 units right here. But what's that distance? It's just 5 units. So when you get a problem just like this, where it doesn't have the real and the imaginary, and you're used to drawing right triangles, again, try not to memorize. If you just understand the concept of absolute value, which is distance from 0, what's the absolute value of 5i? It's 5. What's the absolute value of negative 5i? Still 5. Still 5 units away from 0. So if you have questions, not a problem. I know the complex numbers can sometimes be a challenge for students, but if you remember the form of a complex number, which is a plus bi, you should be in good shape. Look forward to seeing you in class.